Okay, my name is Sabyasachi Bhattacharya. I woke up 4 o'clock in the morning to come to here from Kolkata. Pardon, my Tamil is as good as your Bengali probably is, so I will stick to English. We will talk about big data analytics. I work for Accenture, and in the India Delivery Center, I look after Oracle BI and Analytics. So while we will talk about big data analytics in general, we will also touch upon what I work on, and also Oracle is sponsoring this session, so there will be a connect on that. So what is big data? Is it just a hype? Everybody, every year or every decade there will be some new technologies, new jargons that will come up, right? So in last few years, we are all have been listening to big data. So what it is? I'm sorry. Before, yeah, I'll start with one of my favorite quotes on technology, and it comes from Einstein, that without changing the patterns of our thought, we will not be able to solve the problems which we are created by the current patterns of thought. So all of you are familiar with relational database which were holding data that was formed on the basis of Codd's relational theory, and it came in 1969. Oracle came up with Oracle database and went for its IPO in 1986. Then in 1995, we got MySQL, which is a commoditized version of relational database. So it took from 69 to 95, 26 years for relational database to come from a research paper to everybody's day-to-day life. And if you look at big data, it started 10 years back when Google came out with a epoch-making paper on MapReduce. Have any of you heard of MapReduce? Anyone? That's the paradigm of programming for big data. Now, that was just 10 years ago. While we have seen that it took 25 plus years for relational database technology to be really mainstream and up to the consumer. Within 10 years, it is impacting every sphere of our life. If you look at the things that are driving this big data, what is driving? The number of internet users. Today, there are 3 billion internet users. Mobile handset, 6 billion. Any idea what is the population of world today? What is the global population? Anyone? Any estimate? It's 7 billion. With a 7 billion global population, there are 6 billion mobile phones today. Okay, most of you have more than one, so it may not be 6 billion distinct people, but still it's a big number. 6 billion mobile phones in a 7 billion world. Okay, by 2020, only the internet commerce transactions, your Flipkarts, your Amazons, Things like that. Myntra.com, you don't go to retailer now, buy everything online. Only that business will be 450 billion transactions per day. That is the real event, that is the real scenario which is driving this big data. So all these events, Facebook every day, it processes, it analyzes 30 petabytes of data. Any idea what is a petabyte? A petabyte is 1024 terabyte. And 1 terabyte is 1024 gigabyte, which is 1 gigabyte is 1024 megabyte. Okay, so everybody knows GB. Your mobile memory is also in GB. Your laptop, desktop memory, your disk space is also in GB. So everybody understands GB. So today's desktop laptops comes with probably half terabyte or 1 terabyte of hard disk. And Facebook analyzes 30 petabytes, which is 30,000 terabytes of data. And what does it do all of that for? So that it can give you the right links while you are on your wall. The right advertisements comes, you go to the right place so that you make a transaction and they earn money. Okay, so that is the name of the game which is changing. Is it the only thing that is changing? Within the enterprise there are pain points. I come from a commercial enterprise. We do business for, we serve other commercial enterprises, right? Where they do business, and in that enterprise, in that corporation, things are changing. What is changing? Earlier, there were limitations in how much data they can process. Because of cost, storing the data was costly. Today, there are cheaper alternatives and technologies available where you can store the data for far longer. You do not have to purge the data. You can keep the data online forever. You can see your Googles, your Google Mails and your Facebooks and Twitters, they provide almost unlimited storage for you. That is possible because they are using big data technology which is enabling cheap storage of large volumes of data. So there is no data regret anymore. That was the pain, that we cannot use all of the data because we cannot hold so much data because it costs us. The cost is less. That was one point. Second point was, it's not only the storage inability to store data, inability to process also. Second point, why inability to process? Because the processing takes time. The computational capability of our systems were not that high. So while I need some data to be processed every day, every week, every month, my capacity to process so much data within that time frame was limited. So I could not have processed so much data. So it is not only that I cannot afford to store because it is costly, but even if I stored, my computational capacity was not there to process so much data. That was the second pain point. Third pain point is, not only I cannot process, even if I can process today, tomorrow if the business comes to me and asks a new question, I need answer to this question. This is my new business problem. I have to go back, find out where the data will be obtained, get the data, develop the code, put it into production, fetch the data, do analysis, and produce that end result to my business user. All that process would have taken 3 months to 6 months. So there is a development life cycle. There was a development life cycle. So you understand the pain points that were there with the traditional technology. The way we were managing data. Number one, it was costly to store large data. Number two, it was it was time consuming to process so much data, capability to process was also less, and the third and most important thing, our delivery life cycle, our development life cycle was also very slow. We could not adapt to the quickly changing scenario, quickly changing market demands. So those were the pain points. We used to sample data because our computational capacity was limited. We could not have processed all the data. We used to take samples of data and analyze because we did not have the computational capacity. We did not have the CPU capacity. So, how do you know that you have reached a stage when you are processing big data? How do you know? You will see, if you Google, you will see a lot of definitions of big data. It has three characteristics. One, it is called 3 V's of big data. What are the 3 V's? Big volume, big velocity, and big variety. 3 V's. Remember these 3 V's of big data. I am not going into that because you can Google and you can find out. So otherwise, when do you understand you have reached a problem of big data? When your conventional technologies of managing data, analyzing data is reaching a kind of limit, when the size and performance requirement of the data is forcing you to change your thought process of how you will store, process and analyze the data. At that time you know you are into a big data problem. So sheer size, complexity, variety and speed of data is forcing you to change your strategy of how you will handle the data. At that point you are in a big data problem. So it will consist of the traditional corporate data, which is your very structured, well-structured data, relational data. It will have all the unstructured data. It will have your data like text data, free text, documents, videos. All kinds of data will be part of your big data platform. So if you are going for those kind of analytics, those advanced analytics which you need to run on very large volumes of data, you are in a big data problem. You are in that big data domain. Now, the traditional, as I was telling earlier, the traditional tools that we had did not have the capacity to handle these volumes of data economically and efficiently. So I don't know whether the slides are very visible from the back, but what this slide tells is it starts with a very interesting quote from the analytics lead of Twitter, Kevin Well. He says, today, for your generation, it is very easy to get the right answer. So, for a specific pointed question, finding the answer is very easy. You go to Google, you find out. What is important is, what is hard, the harder part is to ask the right questions. Okay, so getting the right answers is not hard anymore. If you know the question, there is an answer out there, you can very easily get it. But are you asking the right questions? That is the hard part. Once you ask the right, once you know the method to ask the right questions, the more questions you ask, more right questions you ask, more possibilities open up, and you get into more insights from that data. And those are the tools and technologies, the techniques that you will apply on big data for getting those answers, those kinds of answers. So this is how two different worlds are coming together. The traditional IM is information management. So that's my background. That is where we have grown up as a professional, managing information the traditional way, which meant it is very strict. All information goes through a very strict information management process. There are quality gates put at every point. So it's not that everything that goes around, every data that is around gets into my system. There is very strict toll gates put in on the road, which will put checks on what gets in. They must be adhering to quality norms. It's a slow process. It's a top-down process. It starts from your requirements, your business requirements, what the requirement is. You gather that requirement, then you find the data, you let the data pass through all those standard processes, and then only you go to the world of the analysis, the meaning out of that data. So it's a world of data warehouse, very strict process, electronic content management. The lingua franca there is SQL. It is primarily relational data. So you have, and over the years, over last 10, 12 years, every corporation has built those competency centers. And the quality of data there, perfect. You compare to big data world, every child will get the education. So big data is similarly no data left behind. Anything that is out there is welcome. Everything is welcome. So it's an embracing technology. So you get the data in fast. So the big data, it's completely different. It's not those suited things. It's those casuals. Everything comes in. It is more about experimentation. It's not top down. It's bottom up. You get the data, then you look at the data. Then you start investigating the data. That's where you get the charm of the data. You find the meanings in the data. You mine the data. You get meanings out of data, and you find new business out of it by mining the data and getting new insights from that data. So that is taking this traditional process totally upside down. However, in a corporation, they both coexist. Now, an enterprise cannot be left to some geeks only, okay? Because the enterprise has some responsibility also. There is a financial reporting that needs to be done. It cannot have bad quality data. If your financial reporting goes, it's just poor data, your entire reputation will go. Your company's goodwill will go. So there needs to be processes also, as well as there needs to be innovation, which is coming through these new technologies. So there is a mix of both technologies. Coming to Oracle, I will conclude with a few bits of things on the Oracle front. In Oracle has been a database company all along. So we have Oracle database. Now, in the dotted lines you see, those are the analytics technology. And outside the dots, there are hardwares and softwares which are for handling big data. So the database itself can store big data, and then there is the extension of the database with a massively parallel processing storage systems called Exadata added to the database. So that's the relational data stored in a highly parallelized access pattern. And then there are Oracle Big Data Appliance, which is open source big data combined into with Oracle's hardware, and the pain of putting together all the big data platform on your own is taken away by Oracle, and they are giving you in a box on all the components, all the pieces of the big data environment in one appliance. So that's the big data appliance. And then there are softwares like OBIE, which is the reporting tool. Then there is Endeca Information Discovery, which is for unstructured data analytics. And R is for advanced analytics, algorithms. If you have heard of SAS, it used to be deployed for analytics on advanced analytics, predictive modeling, where your objective is to predict for the future, those kind of things. Now, the challenge, the way Oracle is approaching this problem, and many other vendors are also, is to put that analytic engine into the database, if the data is in the database, or if the data is in the big data platform, the Hadoop platform, the big data appliance, then the analytics should happen where the data reside, that is, i.e. in the Hadoop platform, in the Hadoop data store. So that is the new approach of analytics which is required for big data. Because the volume is so high, you cannot bring all of the data out of the data store into the analytic engine and process. That kind of bulk uplifting of the data, bulk lifting and putting the data back into the data store is not feasible. So when Muhammad cannot go to the mountain, mountain needs to come to Muhammad. So you bring that analytic engine into where the data is. That's the new strategy. That is where Oracle has put together its solutions, and that's how we build. If you look at, pardon my challenge with this pointer device, but that is the kind of platform. So you get different data sources. It can be internal, it can be external, social media, all of that data without any challenge. Okay, sure. Without any challenge, that all of that data is coming into that big data appliance, and then all the data warehouse processes, all the your information management processes can handle that. You have your relational data in Exadata, and Exalytics is that in-memory machine where you are doing all of the BI analytics on that. So I will, in the interest of time, I will move around those, and I'll just say what all of that means to you. As a career option, there were different profiles earlier in the organization. So someone was specializing on the data. Someone was a statistician who understands the algorithms, who understands the mathematics behind analyzing data. There were business analysts who were specialists in business. Operations research, optimization, operations optimizations and all sorts of algorithms. And computer scientists who brings all of that together in the computing device. All these careers, all these profiles have merged into today in something called data scientist. And as Harvard Business Review says, it's the most exciting career option for 21st century. Many of you will probably be there and will contribute and take this profession ahead. So that's where I will conclude. That is the whole purpose of big data analytics. It's the job of a data scientist. It requires the skills of all those that I told before. So in this half an hour presentation, the objective was never to teach you about big data analytics. It's not physically possible, but hopefully I could give you some pointers so that you can take it forward on yourself, and there is no limit to the methods of learning today. So if I have been able to entice some interest in you on this technology, then I would think my this one day's effort of coming here is successful. Thank you very much for your patient hearing.
Thanks a lot, Mr. Sabyasachi Bhattacharya, for that informative session. Now